main priority because it's what's on the test for Thursday.
Okay.
And the stuff for tomorrow I'm pretty good on.
Okay. All right. Yeah. So I got number one. I'm about to snip in, and we'll take a look at. I feel like we did something like this last week, but I don't
Yeah.
recall. So it says solve. Solve means to get X. There are exclusions, and you get these by setting the bottom equal to 0. So X equals 0, X equals -3. These are the excluded values. These are the values that if you get them, you have to say no solution. Did you guys talk about that in class? Maybe the word extraneous came up.
Yes, exchange.
Okay. Yes. And really they're outside of what's called the domain, which is why they are excluded. Okay. Now to solve this, you have to determine the common denominator. What any idea what that is for this problem?
+3, X +3.
So these are actually considered in parentheses. So you've got an X +3 and an X.
So you add a X +3 and then add a X to each side.
Yes. So we're gonna write X +3, X +3, X, X, and then over here on the right, it's X and X +3, X and X +3, like that. Is that okay so far?
Yes.
All right. Now, the bottoms are all the same. Do you agree with that?
Yes.
So when the bottoms are all the same, you can just look at the top. 2 times X +3 plus 5 times X equals 2 times X +3. And you have to solve this equation. All right, so let's distribute in here. 2X + 6 plus 5X equals, this becomes 2 times X, and then you're multiplying it by X +3. So that becomes 2X squared plus 6X. And then on the left side, you can combine like terms. You've got 7X plus 6. This should all be reviewed, things you've seen before. Nothing unusual about this. Is that okay?
Yes.
All right, now you do want to move everything to one side, and the preference will be to move things to the right. All right, so it's got 2X squared minus X minus 6. And then you set this equal to 0. Now it's kind of a completely new problem to solve, but one that you've seen before. Do you remember how to solve something like this? How to factor this when it's not a 1 in front?
I don't.
Okay, so you start by multiplying the first and the last.
Oh,
So
4.
2 times -6, which is -12. And they're trying to find two numbers that multiply to -12, but add to -1. What would those be? What could those be? Like, for example, -1 and 12, they multiply to -12, but they don't add to -1.
-4 and 3.
Yes, and that does work. That does work. So this becomes -4X plus 3X, like this. And then you're splitting apart that -1X into the two things. And then you are going to take the GCF of 2X squared and minus 4X, which is 2X. And so inside parentheses, you get X minus 2 x minus 2. You immediately write that off to the right there. Does this starting to look more familiar?
Yeah.
Okay, and then you have to figure out what goes in the middle here, such that when you multiply in, you get 3x minus 6.
So 3.
Yes. Plus 3. All right, so then you can factor out an x minus 2 from both, and that's 2x plus 3. So now you're setting both of these equal to 0. X minus 2 equals 0, 2x plus 3 equals 0. You get x equals 2, x equals minus 3 over 2. And then you ask yourself, well, are those any of the excluded values? Are these extraneous?
No.
And they're not. So these are both solutions. Any questions on that? Thoughts
No.
on that?
Good.
Okay. All right. Okay, so where that leads us is to the next one. It's an inequality, number 2. It's really similar. It ends up being really similar to what we just did, but let's take a look at number 2. All right, and these are kind of long. The first thing is you do want to figure out where the bottom equals 0. 3x plus 1, where does that equal 0? Can you tell me where that, what the x value is, where that is 0?
Um.
Can you solve that equation? Move the 1 over and divide by 3.
One-third.
Negative 1/3. You're subtracting 1 from both sides. 3x equals negative 1, divide by 3. Okay, so this is excluded. Okay, and in this case, it's going to be a point on the number line, which we'll get to in a bit. But that's really important to figure out that excluded value first. All right, then the next thing here is to move the 2 over to the other side of the equation. I know this looks odd because you're like, why would you do that? Why wouldn't you just cross multiply or something? But this is the right approach here. Although I guess you could do that. How are you guys doing this in class?
We're subtracting the 2 or
Yeah, okay. Yeah, that's what I figured. Because there is kind of a shortcut, but
and then distributing the 2 into the whatever.
oh, you are. So you are multiplying this by 2?
Yeah.
Oh. So you can do that. I mean, that's not really the right way to do it. It's a shortcut. It does work, but it's not ideal. Um the better way, I guess we can do that. Yeah, let's do it the way you're doing it in class. So I was going to make a common denominator and such like that, but uh, let's do what you just said. 3x plus 8 less than or equal to 2 times 3x plus 1. You're going to distribute the 2 into both these, so it's 6x plus 2. Do you remember how to solve this from class?
You had to combine like terms.
So you have to move some things around, um, which could be Could be tough. The main thing here is to get x on the left. One of the problems, though, if you move the 6x left, is you're going to have a negative in front. You move the 8 to the right. It ends up being minus 3x less than or equal to minus 6. And you get this situation where you divide by a negative. So when you divide by the negative 3 on both sides, do you remember what that does to the inequality?
It flips it.
Yeah. So the mistake with doing it this way, I mean, there's nothing wrong with doing it the way you've just done, is if you don't do this excluded part first, you might think your answer is correct. And it kind of is, but it kind of isn't. Like you're missing part of it, with this. And that's
Yeah.
right. Are you sure you guys are doing it this way in class?
Um, she sets it up a little bit differently. Like the way she would have us set it up is the original fraction, and then next to it she would do 2 parenthesis 3x plus 1 parenthesis over 3x plus 1 and make it a
Okay.
common denominator, and then only take the top.
Yeah, and that's really what I wanted us to do. I misunderstood. I thought, I mean, this is okay, but this is
She's
not the right
also
way to do it.
done
So
it this way.
say that again.
She's also done it this way.
Okay. All right. Well, this is good. I mean, we can go with this. But we're missing. See, the problem is we're missing part of the solution, which is why this way is not good. So I'm trying to decide what to suggest here. Okay, let me go back. I mean, really, this is not. So what we should have done here is done this 3x plus 8 over 3x plus 1 minus 2 over 1, and then 3x plus 1, 3x plus 1, and you're setting it now equal to 0, and you find that it equals 0 because it's the same thing you just did. I guess I shouldn't have erased all that, but it ends up being at 2. So now on our number line here, we have two problems. We have at 2 and at negative 1/3. Okay, and then we're supposed to test points. Did you guys test points in your
Yeah.
calculations? Okay. And that's what I feel like we're missing here is this the testing stuff. So we should test like 0, we should test like maybe -1, and then like maybe 3. And we're really testing in back in the original. It's always better to go back to the original, which could be kind of a hassle here. But zero is not too bad. 0 becomes 8 over 1. That's 8. Is 8 less than 2? The answer is no. That's excluded. 3 times 3 is 9, plus 8 is 17 over 10. 17 over 10, is that less than 2? And the answer is no. I'm sorry, it is. That's okay. Are you guys testing it in the original or somewhere else?
We are testing it in the original.
Okay. And then so -1, you're going to find that it ends up being also okay. Now the problem is that you have to also remember that -1/3 is excluded, so that's an open circle. The 2 is included, so it's a filled in circle. So it's all this stuff to the right and all this stuff to the left. All right, so your final answer ends up being, based on this number line, ends up being -infinity to -1/3 union bracket 2 to infinity. The bracket because it can be that value. Any thoughts on that?
No.
Okay.
Actually, will you go over the how like the negative infinity and stuff? Can you just go over where it goes and stuff so I how you get
Yeah,
it?
it's good to put those at the end points of the number line. And then whatever shaded that corresponds to a region in here. And then you're just trying to figure out if it's parentheses or not. So with infinities, it's always parentheses. With the numbers, it could be either. It depends on whether you're including them or not. Um, these end up being filled in. These are not. Brackets. It's kind of your chart here, if you will.
And then what? How do you determine if oh, never mind. Because if it's negative infinity, it's in front, but positive
Yeah,
infinity is on the right.
that's right.
It's always
Yeah.
going up. Okay. Okay, that makes sense.
Okay. Um, the one you've got the star next to is really similar to it. Do you need it to go through that, or do you feel like you
That
have?
one I'm good on.
Okay, it's really similar. Looks like you'll get something like that on your test, since they gave you two on this warm up thing.
Yeah.
Okay, number four. Number four is an absolute value problem. So your goal is to isolate the absolute value of 5x minus 3. So basically, anything besides that, you want to move to the other side of the equation. So in this case, you're going to undo plus 4 by subtracting 4 from both sides of the equation. Okay. So now there's kind of like case one and case two. There's the positive, there's the negative. Do you remember this from class, or is that?
Yes.
Okay, so 5x minus 3, that's always the same, equals the positive. 5x minus 3 equals the negative of that number. And if you're willing, why don't you try solving this?
Mm, 7/5.
Okay.
-1.
-1 divided by
5.
5. Good. Okay. That is it. Okay. Number 5 is a little bit odd here. Uh, First thing is kind of like the first problem you did. You really have to keep in mind what your domain is in this problem. You have to say to yourself, okay, what's reasonable? Um, the numbers under the square root here, they have to be greater than or equal to 0. So x has to be positive. So if you get a negative number, it will not be correct because you cannot take the square root of a negative. And we'll see that at the end, but sometimes it's good to know that in advance. Now, did you do any problems like this in class?
Um, we have it, and I had one of these on my quiz and did not know how to do it. But
Yeah,
I
so
have
the U here, the U is a substitution, and you always make U the middle term. All right, so when you square U, you're squaring the square root of X, which becomes just X. So you end up replacing for these two. So instead of X, it becomes U squared. Instead of square root of X, it becomes U. And then this is something that you can solve. And you do this by subtracting 42 from both sides. So you end up getting U squared minus U minus 42 equals 0. So you're looking for two numbers that multiply to negative 42, but then add to negative 1. This is the standard factoring.
6 and -7.
6 and negative 7, so it's U minus 6. Sorry, U plus 6, U minus 7 equals 0. So you solve for U, and you end up getting U equals negative 6, U equals 7. Right? And so from here, you have to go back to your original equation. So instead of U, you set the square root of X equal to negative 6 and the square root of X equal to 7. And then how do you undo the square root?
Um, Squaring both sides.
Yeah, so X equals 36 and X equals 49. There you go. There are your answers. The key is to remember the substitution. Until someone tells you, you would have no way to know. You just would never figure it out.
So I just have to remember to put it back in.
And back, yeah. Because it's easy to get to this line and think you're done. You probably get a little more than half credit, but not full credit um, for that.
Okay.
All right. Any questions before we proceed?
No.
All right. All right. Yeah. So let's message. Okay. So the next one here is number 6. This one is solved kind of more like how it says you solve this the way you've solved other equations where you're just trying to isolate X, the variable. So you start by adding 16 to both sides. X minus 4 to the 2/3 power equals 16. All right. And then this one's a little bit a little bit more difficult. If you recall, the square root of x is really x to the 1/2. And to undo it, you raise it to the 2/1 power. All right. And then what that means here for the left side is that you're going to um, raise both sides to the 3/2 power. Like that. Which is a little bit weird, but that is what is required. Um, on the left, it just becomes x minus 4. So you always take it to the reciprocal. If it's 2/3, it becomes 3/2. Now on the right here, you have to rewrite 16 as something to a power. And there's a couple of options here, like 16 is 2 to the 4th, 16 is 4 squared. To decide, it's like which is better to the 3/2 power. And it just depends what you're more comfortable with. Like 4 squared to the 3/2 power is 4, 2/1 times 3/2. That ends up being 4 cubed. And 4 cubed is 64. So there's like a lot that goes into just going from, hey, it's 16 to the 3/2 power down to, this line here. There's all this stuff in between that you have to be able to do. Is that okay?
Yeah.
And then you're going to finish the solving by adding 4 to both sides. So x equals 68. All right. We've got time for more questions. I can make some up like some of the ones we've done, or if you've got some others you want us to solve, let me know.
Can we do similar ones, or can you make problems?
Yeah, I mean, what's the order here? Like, which ones do you want more
Um,
like?
one like number 4 and number 1.
Okay, so let me give you another one like number 4 to try on your own here. All right, why don't you try that?
Um, x equals 2/3 and x equals -2.
Okay, let me just work this out just in case you want to see the steps later. But if you subtracted 6 from both sides, you get two equations. 3x plus 2 equals 4. 3x plus 2 equals -4. And those are both correct. So good. All right. So I found a few that are like number 1. It's hard to get them exactly like it because of the there's so many ways the teacher could make these. But yeah, let's try one here. So let's go 3. This is like one. We'll go 3 over x plus 2 over x plus 1 equals -5. So the idea here um, is to get that common denominator. What would that common denominator be for this one?
X plus 1 and x.
Yeah, so you go down, you're like, okay, what am I missing? And that's what you multiply by. So like you're missing an x plus 1 and an x plus 1. You're missing an x, you're missing an x. And actually, let me put this over x because I don't know. I didn't look to see if this one works out. So I know I don't want us to get something that's weird to solve. But this one on the right would be missing an x plus 1. Right. Which means you just have to solve the numerator. So why don't you give that a try? I'll look for one that I know works kind of more like the one you have here. How are you doing on this one?
Good. I'm almost. X equals -8/10, so -4/5.
You said -4/5 like this?
Yes.
Okay. And is that an excluded value?
Um, no,
It is not. All
because
right.
are 3 and 1 the excluded values?
Just 0 and 1. So you would set the bottom equal to 0.
That's right.
So and these are the ones that it cannot be, 0 and -1. Okay, I've got one. I mean, the thing that I just not sure exactly what your teacher was trying to do here. So I can't like, there's so many other possibilities here. Do you want another one like one or something else?
Um, can we Do one of the ones that's the greater than or equal to sign, like number 2 or number 3.
Yeah, yeah, of course. Yeah, that sounds good. Did you get any greater thans in class, or just were they all less thans?
Um, there is greater. I actually don't know. I'm trying to look at a packet right now.
Yeah, I mean, it doesn't change much, but it's like, well, we should consider the other possibility here. So, you want us to try this one? Is that okay?
Yeah.
All right. So first thing is to set the bottom equal to 0, plus 8, and this is the excluded value. So that's going to be a hole in our number line. The next thing is to bring the number over. So bring -5 over. So we have x plus 68 over x plus 8 minus 5 over 1 greater than or equal to 0. This empty space is for the common denominator. That's going to be the x plus 8, x plus 8. So you have x plus 68 over x plus 8. Now you got to make a decision here, and that's why I chose this one is the negative. Do you want to distribute the negative in? Like, do you want to treat this as -5, or do you want to wait?
Um,
How do you see it?
leave it
There's not
as -5.
okay. So we've got the common denominator now, and now you just look at the top, just the top. So you've got x plus 68 minus 5 times x plus 8 greater than or equal to 0. And really, you're just setting it equal to 0 now. Figure out where it equals 0. So could you solve this for x for us, please? Really just where it equals 0.
The x equals 7.
It sounds pretty good. Negative 4x plus 28 equals 0. Yeah, x equals, did you say 7 or -7?
7.
7, good. Okay, so on a number line here, we know that we've got 7 and 8 kind of right there. That makes it tough. I'm sorry, -8. What am I doing here? 7 and -8, and then that's minus infinity, and that's positive infinity. So we're going to test numbers in each region, like 0, maybe 8, maybe -9. And it's up to you if you want to go back to the original, or but probably the original is the best place to go. So you're trying to decide, and start with the easy ones, like 0. Is 68 divided by 8, is that greater than or equal to 5? I know it doesn't go in perfectly, but like, you know 64 divides by 8, and that's 8, so it's a little bit bigger than 8. So this one's good. What about 8? What is 76 over 16? I guess you're not allowed to use a calculator, are you?
On these ones, no.
Okay, so you got to kind of gauge like what's this around? Well, it's 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 between 64 over 16, which is 4, and 80 over 16, which is 5. So it's not quite. And you actually get the same thing here. I think I mentioned last time, like you shouldn't just assume that they alternate, but they actually do always alternate. And you'll start to notice, I mean, there are exceptions to this, but it tends to be when they're greater thans, they're in the middle, and when they're less thans, they're the outside. You've probably even noticed that in your own, work, potentially. But this one just wants it's just from -8 to 7. It includes 7, but does not include -8. The reason is there's that it's not defined right there. Is that okay?
So is there a certain like sign? You know how on the other one we did on number 2, we had 2 points. We had the U in between or whatever.
Yeah. That was
What?
because it was a less than.
Okay. So do less thans always have two answers?
Not always, but probably in your class you will see that. And the greater thans always have in
One.
between.
Okay.
Right, so here's one for you to try or get as far as you can on your own in the time we've got left, if you want to.
Okay.
Um,
Okay. The excluded is x equals -6, and then I
okay,
got x equals 7,
good.
and then putting it
Yeah.
on number line.
So yeah, so because it's a less than, you're already kind of like where it's those are the answers. But you should check. I mean, you should. Yeah, there's a lot of things we should do, but we don't. So I'll leave it up to you if you want to do that.
So the parenthesis -6, comma 7, bracket.
Because this one's a less than, it's the outside. Less thans always become the outside.
That's what we literally just talked about. Okay.
Yeah. All right, that's okay. That's why this is practice. If you ever done yoga, they always talk about practice, and I don't know what you're practicing for in yoga, but in math, you're practicing for your test for sure. Um, so you you know it's a shortcut. Greater than or equal to is the inside or the between. I don't like this, but it will probably work for you in your test.
Then -infinity, -6, and then infinity 7.
A 7 comma infinity with the bracket because it can be that 7, but it cannot be that. And that's all based on whether it's a greater than, less than or equal to, or greater than or equal to. It's that equal to that allows it to be that.
Okay.
Any other quick questions?
I think that's pretty much it.
I'll give you one like 5, I guess, for the road here if you want to try one out. X plus square root of X equals 6. This ends up being well, I'll let you it ends up being 4. It's the only solution to it. Let me do it this way. And it will have 2 solutions. Like we did before. There's a couple variations on this. Like I mean, we can't cover all of them, but just check your answers. I'll just say that. Check your answers always back in the original. Then you will for sure know if they're right or wrong. That one little sign made all the difference on this one, minus or a plus. All right, we're going to stop there.